So double integral and triple integral are some applications of multiple integrals. So both are called simply multiple integrals. Double integral or triple integral are known as multiple integrals. This is an extension of definite integral of single variable. A definite integral means single integration, extension, double integration. What actually double integration means? So double integration means it is a sum. You all know integration means sum. Double integration also is sum, but where that sum we calculate. So double integration, for example, there is a curve like this. There is a curve like this, and there is another curve which is intersecting this one. This region is intersecting region. If you divide that region into n subdivisions, in every subdivision the area is like this, delta y1 in first region, delta y2, delta y3. If you divide into n subdivisions, and in every subdivision the function value is, in first subdivision f of x1 y1, in second subdivision f of x2 comma y2, like this. Then the sum r equal to 1 to n f of xr comma yr into delta yr. If this sum has limit n tends to infinity, if you evaluate, that value is called double integral. That value is called double integral. That is sum of these two products as n tends to infinity. Then this sum is represented like this, double integral f of xy dy dx with particular limits. x1 x2 are x limits, y1 y2 are y limits. So we represent double integration of a function like this one. It has many applications. Using double integration, one can easily evaluate area of two curves intersecting region, and area of curves, volume of curves. Like this, there are more applications on double integration and triple integration. Here, double integral means this one. This is a sum as n tends to infinity. As n tends to infinity, this sum we can call it as double integral. We represent double integral in this way. Now, how to evaluate this double integration? Evaluation of double integral. Evaluation of double integral. A double integral is evaluated by repeated integration. By integrating this integrand function repeatedly 2 times, you can evaluate double integral. So to evaluate this double integral, these limits plays key role. If these 4 limits are constants, like x is 1 to 2, y is 3 to 4, like constants, then you can integrate in any order. First with respect to y, next with respect to x, or first with respect to x, next with respect to y. But if y limits are function of x and x limits are constant, y limits are in terms of x, that is y equal to 0 to x is 0 to 1, then the order of integration is, first you have to integrate with respect to y, next you have to integrate with respect to x. So constant limits, if x has constant limits, you can integrate at the end with respect to x. If y has constant limits, you can integrate at the end with respect to y. But the most important thing which you need to remember is, while integrating with respect to y, keep x as constant. Don't integrate x terms. Integrate y terms only. While integrating with respect to x, integrate x terms. If you have y, then keep them as constant. Like that, one can easily evaluate. The evaluation of double integral is done If 4 limits are constants, then you can integrate in any order. If y limits are in terms of x and x limits are constant, then first integrate with respect to y, next integrate with respect to x. While first integrating with respect to y, keep x constant. While integrating with respect to x, keep other than x as constant. For example, x limits are in terms of y limits are constant, then integrate first with respect to x, next with respect to y. So, a double integral is evaluated in this model. First with respect to y, next with respect to x. Now we are going to discuss few problems how to evaluate double integral. Okay, ma? So evaluation of next integral, ma? We need to evaluate this double integral. Because 4 limits are constant, one can evaluate in any order. First with respect to y, next with respect to x, or first with respect to x, next with respect to y, any order. So now I am evaluating as in given order, like this. First with respect to y, next with respect to x. Like this I am going to evaluate. Integral 0 to 3, integral 0 to 2. I am expanding this one using a minus b whole square formula. A square 16, 2ab 8y plus y square dy dx. Here these limits I am taking as y limits, these are x limits. So as in given order I am taking, as in given order. Whenever limits are in different way, not constants, then we need to identify. I will tell you how to identify when limits are not constant. I will tell you in the next problem how to evaluate limits are x limits or y limits. Now integrate ma, x equal to 0 to 3. Here now I am going to integrate directly. If you integrate 16, integral 1 dy you will get. Integral 1 dy y. Integral y square by 2. Integral y square y cube by 3. Limits ma 0 to 2 dx. Now write in the place of y2. Write in the place of y2 ma. What you will get? If you write in the place of y2, 16 into 2 minus 2 1 jar 2 4 jar 4 into 2 square plus 2 cube by 3 dx. Now 16 2 jar we know ma, 16 2 jar 32, 32 minus 4 4 jar 16 plus 8 by 3 dx. So 32 minus 16, 32 minus 16, 16. If you take 3 LCM, what happens ma? Integral x equal to 0 to 3. Here you will have 16. 16 3 is 48. 48 plus 8, 56 by 3 dx. Now integrate with respect to x ma. What happens? 56 by 3. Integral 1 dx. Integral 1 dx x. Limits 0 to 3. So 56 into, right in the place of x3, 3 minus 0, 56 by 3. So 3 get cancelled. Answer is 56. Are you clear ma? So now to integrate this function ma. To integrate this, here limits are different, not like all constant. For that, to identify limits, I am giving one small technique ma. If limits are in terms of x, they are limits of y. If limits are in terms of x, they are limits of y. That means these limits are in terms of x. That's why they are limits of x. So these are constants. If these are limits of y, then what happens? These are limits of x. That means this is x equal to 0 to 2. Now we need to integrate. I said if y limits are in terms of x, then order of integration will be first with respect to y, next with respect to x. y limits are in terms of x. First integrate with respect to x. These are constant. Next integrate with respect to x. Constant limits integration is at the end. Now integral x equal to 0 to 2. Integral y. Integral y is y square by 2. Limits 0 to x dx. Now write in the place of y x ma. X equal to 0 to 2. I am taking that 1 by 2 as constant. X square dx. What is integral x square ma? X cube by 3. 1 by 2 into x cube by 3. So 0 to 2. Now write in the place of x 2. If you write, what you will get? 1 by 2 into 2 cube. 8 by 3. So cancel. Answer is 4 by 3. 2 4 0. Like that one can easily evaluate this double integral whenever y limits are in terms of x. Next, similar model I am explaining next one. Evaluate same limits. Integral 0 to 2. Integral 0 to x. X plus y dy dx. To evaluate this, first identify the limits. You know how to identify. In this problem I said integral 0 to 2, integral 0 to x, x plus y dy dx equal to. So I said just now, if limits are in terms of x, they are limits of y. That means these are limits of y. Then these are limits of x. X equal to 0 to 2, y equal to 0 to x, x plus y dy dx. First integrate with respect to y, because y limits are in terms of x. So if you integrate with respect to y, don't integrate x, treat x as constant. X constant, integral 1 dy y plus integral y square by 2, limits from 0 to x dx. Now write in the place of yx. If you write in the place of yx, x into x square plus x square by 2 dx. Now integrate with respect to x. Integral x square, x cube by 3, integral x square. So here you can simplify a little bit. Then do like this. X square plus x square by 2 will be, you can simplify, right? 1 by 2 plus 1, 3 by 2. 3 by 2 x square, I am keeping 3 by 2 constant, x square dx. What is integral x square? Integral x square is x cube by 3, 0 to 2. You can cancel this 3. So what is remaining? 1 by 2 into 2 square. 1 2 get cancelled. 2. 1 by 2 into 2 cube. 2 cube. So 1 2 get cancelled. X cube. In the place of x, if you write 2 cube, 1 2 get cancelled. Then what you will have? 1 2 get cancelled. 2 square you will have. 4 is answer. 4 is answer. Clear ma? Now to evaluate next double integral ma. To evaluate these limits are constant, you can integrate in any order. For that, writing this one, integral 0 to 3, integral 1 to 2, I am multiplying this one. Xy into 1 xy plus xy into x square y plus xy into y, xy square dy dx. So now you can integrate first with respect to y, next with respect to x. Now integrate with respect to y ma, what you will get? Integral y square by 2. Integral y square by 2 plus y cube by 3 dx. Limits 1 to 2. Now write 2 first ma. Now write 2 first. What you will get? 2 square by 2. 2 square by 2, 2x plus 2 square by 2, 2x square plus, right in the place of y2, 2 cube, 8, 8 by 3 minus, this is you substituted in the place of y2. Now if you substitute lower limit y equal to 1 in this, y equal to 1, x by 2 plus x square by 2 plus x by 3 dx, x by 2 plus x by 3. Now integral 0 to 3, this is 8x, this is 2x, 3 2s are 6, LCM, 3 2s are 6, 6 plus 8, 14x by 3 minus 2x square minus, here these two are same x terms, 2 into 3 6 LCM, 3x 2x, 3x plus 2x 5x, so 5x by 6 plus x square by 2 dx. Now simplify now, integral 0 to 3, here 14x by 3 minus 5x by 3, 6 LCM, 2 14 are 28, 28 minus 5, 23, x by 6, by taking 6 LCM, 6 LCM, 3 2s are 6, 2 14s 28, 28 minus 5, 23, next x squares, the 2 you are having, 2 2s are 4, 4, minus into plus minus, so minus 4x square minus x square, minus 4x square minus x square minus 5x square by 2. Dx. Are you clear, ma? X by 3, x by 2, 5x by 6, this is okay. If you subtract, this one is okay, ma. Here, plus into minus minus, 2 2s are 4, here plus 2x square, right? Plus 2x square, right? 2 2s are 4, 4x square minus 4x square, if you multiply with minus, here plus only we are having, right? If you multiply with minus, minus you will get 2 2s are 4, 4x square minus, minus into plus minus, 4x square minus x square, 3x square. 4x square minus x square, 3x square by 2 dx. Now integrate with respect to x, what you will get? 23 by 6 x square by 2 minus 3 by 2 x cube by 3. Limits 0 to 3. First write 3 ma. If you write 3, what happens? 23 by 6 into 3 cube, 27 by 2. If you write in the place of x, 3 minus 3 by 2, here x square only, right? 3 square 9, sorry, 3 square 9, 9 by 2. Here 3 cube, 20, 3 3 get cancelled. Here itself you can cancel. So what you will have? 27 only. 23 by 6, 3 square 9, 3 3 get cancelled. Now write in the place of x3 ma, 3 square 9, 9 by 2. Write in the place of x3, 3 cube 47. Now cancel ma. 3 2s are 3 3s are. So 2 2s are 4. Multiply with 3, 3 3s are 9, 3 2s are 6. Minus 27 by 2. If you take 4 LCM, 69 you will get as it is, 69, multiply with the 22. If you multiply with 2, what happens? 2 7s are 14, 54. So now finally what you will get? Here plus 1, plus here you will have plus only, because 2 2s are 4, 4x square minus x square plus 3x square, that is only one correction, plus, so 69 plus 54, 123 by 4 is the answer. Very clear, ma? Here one thing you need to remember, 2 2s are 4, 4x square minus x square plus 3x square. Then you will have plus only 69 plus 54, 123. So we need to evaluate this one, man. So to evaluate this, we all know that these are limits of y. The limits in terms of x are limits of y. That's why these are x limits, these are y limits. E power x plus y, a power m plus n, a power m into a power n. So like e power x into e power y, dy dx. First with respect to x you need to integrate one. So first with respect to y, while integrating with respect to y, treat e power x as constant. E power x constant, integral e power y, limits 0 to x dx. Now substitute man, upper limit and lower limit. If you write in the place of yx, you will get e power x. If you write in the place of y0, e power 0 1. Now multiply. Integral x equal to 0 to 2 e power x into e power x, e power 2x, e power x into 1, e power x. Now integrate, what you will get, ma? Integral e power 2x. Integral e power 2x is e power 2x by 2. Integral e power x. Limits, ma? 0 to 2. So write in the place of x2, next write in the place of x0. If you write in the place of x2, e power 4 by 2 minus e power 2 minus lower limit. If you write in the place of x0, e power 0 1, so 1 by 2, e power 0 1, so e power 4 by 2 minus e power 2, 1 by 2 minus 1 minus 1 by 2, so minus into minus plus 1 by 2 is the answer. Clear, ma? So now we need to evaluate this double integral, but region of integration is not given directly like previous problems. So region of integration, x limits, y limits are not given directly. But region of integration is first quadrant for which x plus y less than or equal to 1. First quadrant means from 0 to 1 or 0 to something. So here the region of integration R, we can take it as x plus y less than or equal to 1. To get limits, I am equating this one to 1. Whenever if you have an equation to find limits, you need to find in this way. One variable limits you need to keep constant. Another variable limit you can take it as limits in terms of another variable. What I am saying, if you want x, y limits, take one variable, x limits in terms of y limits as constant. Or y limits in terms of x limits constant. For that, to get x limits constant, simply write in the place of y0. If you write in the place of y0, then what happens? X will be 1. Then x limits of x are 0 to 1. Now coming to y we are going to take the limits in terms of x, because x limits are constant. You need to take y limits in terms of x. For that, evaluate y value here. What is y value in terms of x? 1 minus x. Then limits of y will be limits of y equal to 0 to 1 minus x. Now limits were evaluated. Now we can integrate. We can evaluate the double integral. Now double integral over R, x square plus y square dx dy equal to integral x equal to 0 to 1, 0 to 1, y equal to 0 to 1 minus x square plus y square dy dx. Because y limits are in terms of x, first you need to integrate with respect to y, next with respect to x. Whenever y limits are in terms of x, first you need to integrate with respect to y, then substitute limits, the total function will be in x, then very easy to evaluate remaining thing with respect to x. That's why first integrate with respect to y. If you integrate, what happens? Integral x equal to 0 to 1, integral y square will be y cube by 3. I said while integrating with respect to y, treat x as constant, don't integrate x. So x square will be constant. If x square will be constant, then what remaining you are having here? Here you will have 1. Integral 1 dy 1. For that, what I am saying, one simple technique while integrating with respect to y, if you don't have y in a term, after integration you will get y. That is one small technique. Without knowing integral 1 dy y, if you don't have y, then write y. Now write in the place of y 1 minus x. Write in the place of y upper limit 1 minus x, lower limit 0. If you write anyway, that becomes 0. That's why write in the place of y 1 minus x mark. X equal to 0 to 1, x square into 1 minus x plus 1 minus x whole cube by 3 dx. So multiply the first term as it is, x square into 1 minus x, what you will get? X square minus x cube plus 1 minus x whole cube by 3. If you want, you can expand 1 minus x whole cube using a minus b whole cube. Otherwise you can keep like that only. We can integrate by treating this one as x using x power n, integral x power n formula. So integral x square x cube by 3, integral x cube x power 4 by 4, integral 1 minus x whole cube 1 minus x whole to the power of 4 by 4. And one thing you should not forget, that is, after integrating the differentiation of internal term, you need to write in the denominator. Differentiation of 1 0, differentiation of x 1. So minus 1 you will get. So now write in the place of x 1, what you will get? 1 by 3 minus 1 by 4 plus into minus 1 by 12. Okay, 1 by 12. If you write in the place of x1, what happens? 0. So I written here plus into minus, lower limit I am substituting. 1 by 12, 0 you will get, minus lower limit. Anyway, if you write lower limit here, 0, 0. Here if you write in the place of x0, what you will get? 1 by 12. Upper limit minus lower limit. Then what happens? This is lower limit value. 1 by 3 minus 1 by 4. 12 LCM, 4 minus 3, 1 by 12. Here minus into minus plus 1 by 12. So if you take 12 LCM, you will get 2. 2 1 are 2 6 are 1 by 6 will be the answer. Here no confusion, this is completely upper limit minus lower limit. This is completely upper limit substitution. When you write in the place of x1, 1 by 3 minus 1 by 4, 3 4 are 12, 12 into 0, 0. Minus, if you write here in the place of x0, 0, 0. Here, if you write in the place of x0, 1 by 12. Okay, so 1 by 12 you will get. Then minus into minus plus. So that is remaining. 1 by 12 plus 1 by 12, 2 by 12, 1 by 6. So evaluating double integral. To evaluate this double integral, these limits are in terms of x. So they are limits of y. These are constant limits. So they are limits of x. What I am saying, these are limits of x. These are limits of y, x to root x. Okay. Now I am going to integrate first with respect to y. For that, I am keeping this x square as constant, x square constant. Now I am multiplying this one with y square. What you will get? xy square plus y cube dy dx. So x equal to 0 to 1. Now integrate with respect to y. Integral y square y cube by 3. Integral y cube y power 4 by 4. Limits from x to root x dx. Integral x equal to 0 to 1. Write in the place of y root x. X into root x. This x square is there, this x square will be there. X square constant, that x square you can keep like that. X into root x whole cube by 3 plus root x whole to the power of 4 by 4 minus. Now write in the place of y x into x cube by 3 plus x power 4 by 4 dx. Now integral x equal to 0 to 1 x square into root x whole cube. Root x is whole power 1 by 2. Whole power 1 by 2 whole cube means x into x power 3 by 2 by 3. Clear ma? Root x whole cube x power 1 by 2 whole cube x power 3 by 2 a power m into a power n formula plus root x whole square root x whole power 4 root x whole power 4 can be written like this root x whole to the power of 4 root x whole square into root x whole square root x whole square is x root x whole square is x into x square. That's why here we will have x square by 4 minus see here x into x cube x power 4 here x power 4 both are x power 4 terms. Then you can take 12 LCM. If you take 12 LCM, what happens? 4x power 4 plus 3x power 4. 4 plus 3, 7x power 4 by 12 dx. Clear ma? Now I am going to multiply with x square these all terms. If you multiply with x square these all terms, what happens? Integral x equal to 0 to 1 multiply with x, what happens? See, x square into x cube into x power 3 by 2. That means here you will have 3 plus 3 by 2. So what you will get ma? 2 3s are 6, 6 plus 3 9. So finally x power 9 by 2 by 3. Clear? Next, if you multiply this one with x square into x square, x power 4 by 4 minus multiply again this one also with x square x power 6 x square into x square x power 4 x square into x power 4 x power 6 by 12 dx. Clear ma? Any doubts you can express. Here multiplication only x square into x cube 3 plus 3 by 2 you will get that I written as 9 by 2. Now here I am going to use integral x power n. Integral x power n is x power n plus 1 by n plus 1. Like that, if you multiply, if you apply that formula here, 1 by 3 into x power 9 by 2 plus 1 by 9 by 2 plus 1. 9 by 2 plus 1, 9 plus 2, 11. So x power 11 by 2 by 11 by 2. Now 1 by 4 will be there. Integral x power 4, integral x power 4, x power 5 by 5 minus 7 by 12. Integral x power 6, integral x power 6, x power 6 plus 1 by 6 plus 1, x power 7 by 7. Limits 0 to 1 mark. So here 7 get cancelled. The remaining will be like that only. 1 by 3. This 11 by 2 you can take it here. 2 by 11 you will get. 2 by 11 means 11 3s are 33. So this can be written as 2 by 33. Because I am substituting in the place of x1, 1 power anything is 1. So there, wherever you will have x, there you will get 1. Wherever you will have x, there you will get 1. So here 1 you will get, this is 2 by 33 plus 4 5s are 20, 1 by 20. Next, this 7 get cancelled, 1 by 12. Now we need to simplify this one by taking LCM. If you take LCM, 2 3s are 6, 2 3s are 6. 660 will be LCM. 660 will be LCM. Then what you will get? 33 into 20. 22s are 40. 20 into 33 you will get 660. So you will have 33 here. Now divide this one with 12 so that you will get the value which you need to subtract here. 660 by 12. 660 by 12 means what you will get? 12 5s are 60. You will have one more 6. Again 60. 12 5s are 60. That means 55 you will get. Now add 40 plus 33. 73. 73 minus 55 you need to do. 73 minus 55, 18 by 660. So that is the evaluation of this double integral. Any doubts you can express, ma? So double integration in polar coordinates, ma. Previously we discussed in Cartesian coordinates, that is x-axis and in y-axis. So the limits will be x and y. In polar coordinates, the function will be like this, r and theta. R and theta. So to integrate this function, the limits will be like this, r1, r2, theta 1, theta 2, dr, d theta. So to integrate this type of function, what is the procedure we are going to follow? Similar, if r theta limits are constant, you can integrate in any way. If theta limits are in terms of r, first integrate with respect to theta, next integrate with respect to r. If r limits are in terms of theta, first integrate with respect to r, next integrate with respect to theta. If r theta are different limits, constant limits, then you can integrate in any order. So this we can understand very clearly with an example now. So evaluate integral 0 to pi integral 0 to a sin theta r dr d theta. R dr d theta. To evaluate this, first identify the limits. Which limits are theta limits, which limits are r limits. As I said in Cartesian system, like that only here. If limits are in theta, they are limits of r. If limits are in theta, they are limits of r. That means these are in theta. That's why these are limits of r. The remaining limits will be theta limits. So these are theta limits, these are r limits. Then how to evaluate this? Integral theta equal to 0 to pi. Integral r equal to 0 to a sin theta. R dr d theta. Just now I said, if r limits are in terms of theta, then integrate first with respect to r. Which variable has constant limits? That variable will be integrated at the end. Here theta limits has constant limits, so finally the last one integration, last with respect to theta we are going to integrate. Integral r dr. What is integral r? Integral x square by 2, integral r square by 2. Limits 0 to a sin theta d theta. Now write in the place of r a, take 1 by 2 here, constant, theta equal to 0 to pi, write in the place of r a sin theta. A square sin square theta d theta. So a square is constant, a square by 2, integral theta equal to 0 to pi sin square theta. So you know sin square theta is 1 minus cos 2 theta by 2, sin square theta formula. So that's why I am writing here 1 minus cos 2 theta by 2 d theta. Now integrate, 2 2s are 4, a square by 4 will be here. Integral 1d theta theta. Integral 1d theta theta. Integral cos 2 theta sin 2 theta by 2. Theta equal to 0 to pi. After integration, just now I said the differentiation of this term you need to write in the denominator. Differentiation of 2 theta, 2, that term I written. Integral cos sin. Integral cos 2 theta sin 2 theta by 2. Now you all know that while substituting upper limit and lower limit, for upper limit, if you write theta equal to pi, what happens? Sin n pi is 0. Sin n pi, sin any pi, sin 2 pi, sin 3 pi, sin 4 pi, 0. So here sin 0 is 0. That's why if you write in the place of theta pi minus sin 2 pi you will get sin 2 pi 0. This is upper limit. If you write in the place of theta 0, sin 0, 0. So what you will have? Pi only. So answer is pi a to the power of a square only, right? Sorry. A square. Pi a square by 4. Pi a square by 4 is the answer for this problem. Like this, one can easily evaluate double integral in polar coordinates. Just like Cartesian only, but there you will have xy, here you will have r theta. Clear, ma? So evaluate this integral. For that, I am evaluating this integral in the same order. First with respect to theta, next with respect to r. So integral 0 to infinity, integral 0 to pi by 2. These are theta limits. These are r limits. Theta equal to 0 to pi by 2. E power minus r square r d theta dr. Now what happens here? This is constant. While integrating with respect to theta, this term is constant. Integral 1 d theta. Integral 1 d theta is theta. Then r equal to 0 to infinity. Integral 1 d theta theta e power minus r square r will be there. Integral 1 d theta theta, write in the place of theta 0 and pi by 2. So if you write in the place of theta pi by 2, what you will get? Pi by 2 will be here. Integral r equal to 0 to infinity e power minus r square r dr. This one we need to evaluate. To evaluate this one, so we have to integrate this one. To integrate this one, if you have differentiation of this term here, then we can use one formula, that is integral f dash of x into e power f of x dx equal to e power f of x. To apply this formula, what I am doing, differentiation of minus r square, minus 2r. So I am multiplying this one with minus 2 and dividing with minus 2. Next we will apply this formula here. Are you clear, ma? Differentiation of r square minus 2r. So if you assume minus r square as t, differentiation of minus r square minus 2r dr, then integrate integral e power x e power x. So what you will get? You will get after integration 5 by minus 4 e power minus r square r equal to 0 to infinity. So this one also you can use integral e power f of x into f dash of x dx equal to e power f of x. Similarly, e power minus r square is f of x into minus 2r, differentiation of minus r square minus 2r dr. You will get e power f of x, e power minus r square. You all know that e power 0 is 1, e power 0 is 1, e power minus infinity is 0. So what happens here? Minus pi by 4 into e power minus infinity 0, e power 0 1. So finally this will be 0 minus 1 minus 1 minus into minus plus pi by 4 is the answer. Very clear, ma? Evaluating this integral in polar coordinates. Sometimes we may have the problem without region. Region of integration is given, not given directly like this. He will mention that region with a geometrical figure like this. Next problem I will discuss. Evaluate double integral r sin theta dr d theta, r sin theta dr d theta over a cardioid above the initial line, above the initial line. So here the limits were not given like previous problem. We need to evaluate the limits. For that, he had given a cardioid. Cardioid means generally that one also given r equal to a into 1 minus cos theta. Over a cardioid, r equal to a into 1 minus cos theta. Now we need to evaluate this. To evaluate this, as I said in Cartesian form like that, keep one variable limits as constant, another variable limits in terms of another. That means if you keep theta limits constant, you need to write r limits in terms of theta. For that, you need to draw the exact figure of cardioid. So cardioid figure will be like this. So cardioid figure will be like this. On this, above the initial line, this line is called theta equal to 0 line. We call that one as initial line. Above the initial line, cardioid will be like that. So this will be from theta equal to 0 to, this is theta equal to pi line. So now what we evaluated theta limits. Limits of theta are evaluated, theta 0 to pi. So next what I said, you can evaluate r limits in terms of theta, because r value we know. above the initial line from r equal to 0. R equal to 0 to a into 1 minus cos theta. Now limits are evaluated. Theta 0 to pi, r a into 1 minus cos theta. In between these limits we are going to evaluate given integral r sin theta dr d theta. That is double integral r sin theta dr d theta equal to integral theta equal to 0 to pi, integral r equal to 0 to a into 1 minus cos theta r sin theta dr d theta. Because r limits are in terms of theta, r limits are in terms of theta, first we need to integrate with respect to r, at the end we need to integrate with respect to theta. So while integrating with respect to r, keep sin theta as constant. If you keep sin theta as constant, what is integral r? Integral r is r square by 2 from the limits r equal to 0 to a into 1 minus cos theta d theta. Now 1 by 2 is constant. Integral theta equal to 0 to pi. Write in the place of r a into 1 minus cos theta. A into 1 minus cos theta whole square d theta. Now a square is constant and sin theta is here. I forget to write sin theta. Sin theta is there. A square is constant. So a square by 2 integral theta equal to 0 to pi 1 minus cos theta whole square into sin theta d theta. Okay, now we need to evaluate this one more. This can be evaluated like this by assuming 1 minus cos theta equal to t. What you will get after differentiation? Differentiation of cos theta is minus sin theta. That means sin theta d theta will be dt. Then what you will get? In the place of 1 minus cos theta, you will get t. Integral t square, t cube by 3. Integral t square, t cube by 3. That is one way. Another way is, there is one formula. I am writing here, there is one formula. Using that formula also one can easily evaluate this one. What is that formula? Integral f of x whole power n into f dash of x dx equal to f of x power n plus 1 by n plus 1. F of x power n plus 1 by n plus 1. So like that, here f of x is this one. Using this one, integral f of x whole power n into f dash of x dx equal to f of x whole power n plus 1 by f of x whole power n plus 1 by n plus 1. Like that, this will be n. N plus 1 by n plus 1, what you will get? A square by 2, 1 minus cos theta whole cube by 3. Limits from theta equal to 0 to pi. If you assume like this also you will get. Otherwise, if you apply this formula also you will get same one. Now, you need to write 3 2s are 6, a square by 6. Now write in the place of theta pi. If you write in the place of theta pi, 1 minus cos theta. So write in the place of theta pi, 1 minus cos pi whole cube minus 1 minus cos 0. If you write in the place of theta 0. Now you all know that cos pi is minus 1, cos 0 is 1. Cos pi minus 1, cos 0 1. What happens? A square by 6. If you substitute that values, what happens? 1 minus 1, cos pi minus 1 plus 1 whole cube. 1 minus cos 0 1. This becomes 0. So finally 2 cube. What is 2 cube 8. 8 a square by 6. If you cancel with 2, 4 by 3 a square will be the answer. 4a square by 3 will be the answer. Are you clear, ma? Any doubts you may express? Evaluate integral 0 to pi, integral 0 to a cos theta, r sin theta, dr d theta. So limits are given clearly. We need to evaluate, ma. So for that, Directly I am going to evaluate because the limits of theta are constant 0 to pi. Limits of r are in terms of theta. When limits of r are in terms of theta, first integrate with respect to r, next integrate with respect to theta. What I am saying, integral 0 to pi, integral 0 to a cos theta or dr sin theta constant d theta. If you take like that, integral 0 to pi r dr, integral r square by 2, 0 to a cos theta sin theta d theta. Now write in the place of r square a cos theta ma, then what happens? 1 by 2 theta equal to 0 to pi a square cos square theta into sin theta d theta. So a square constant, a square by 2. Here if you assume a square by 2, you will get, if you assume theta equal to 0 to pi, cos square theta into sin theta d theta. If you assume cos theta as t, let cos theta equal to t. What happens? Differentiation of cos minus sin theta d theta will be dt. That means sin theta d theta equal to minus dt. Now limits what happens? Lower limit, if theta equal to 0, what is cos 0? That will be t. Cos 0 is 1. Theta 0 when t equal to 1. If theta pi you know, cos pi is minus 1, t will be minus 1. Now the limits will be like this. A square by 2, cos theta is t, integral lower limit 1, 2 minus 1, cos theta is t, t square, sin theta d theta will be minus dt. So you all know that if you interchange limits, integral a to b f of x dx equal to minus integral b to a. That means if you take minus 1 to lower limit, 1 to upper limit, then what happens? You will get one more minus. Then minus into minus plus. What I am saying like this. Integral minus 1 to 1 t square dt. So why I written like this? In integration there is a famous formula. Integral minus a to a f of x dx if you have. If you can decide this is odd, then that integral value will be 0. If it is even means simply what I am saying, t power even number, t square is a1, t power 4 is a1. Even function means f of minus x equal to plus f of x. If you write in the place of t minus t, if you get same value, then that is a1. So here if you write in the place of t minus t whole square plus t square. If it is even, then you can write this one like this. 2 integral 0 to a. 2 integral 0 to a f of x dx. If it is odd, 0. Then how you can write this? A square by 2 into 2 integral 0 to t square dt. So 2 cancel, a square into, what is integral t square? T cube by 3, 0 to 1. So finally answer, write in the place of t 1, then what you will get? 1 by 3 minus 0. If you write 0, 0, then answer is a square by 3 is answer. Right? This is the answer for this evaluation. Here cos theta we assumed as t. That's all. Remaining thing is nothing. Now to evaluate next problem, evaluate double integral r cube dr d theta included between the circles. Included between the circles. The circles r equal to 2 sin theta, r equal to 4 sin theta. So we need to evaluate this one because this is circle For circle, theta will be 0 to pi. 0 to 2 pi actually, but here we are going to evaluate on positive region, general. So to evaluate in positive region, theta will be 0 to pi. Now, evaluation of r is given. R is 2 sin theta to 4 sin theta. R limits are given clearly. Double integral r cube dr d theta equal to integral theta equal to 0 to pi. Integral r equal to 2 sin theta to 4 sin theta r cube dr d theta. Because r limits are in terms of theta, so first integrate with respect to r, next integrate with respect to theta. So integral theta equal to 0 to pi, integral r cube r power 4 by 4, limits from 2 sin theta to 4 sin theta d theta. 1 by 4 integral theta equal to 0 to pi. Write in the place of r 4 sin theta ma. If you write in the place of r 4 sin theta, 4 power 4 sin power 4 theta. What is 4 power 4? 4 power 4 is 256 sin power 4 theta minus 2 power 4. 2 power 4 is 16 sin power 4 theta d theta. 256, 4 power 4, 2 power 4, 16. Now, what you have? Integral theta equal to 0 to pi. 256 minus 16, 240 sin power 4 theta d theta. 240 by 4 ma. 240 by 4 is 4 6 60. Integral theta equal to 0 to pi sin power 4 theta d theta. So now we need to evaluate this one ma. Before going to evaluate, to use this formula, there is one formula in integration. Integral 0 to pi by 2 sin power m theta d theta formula. To apply that formula, so I need here pi by 2. To get pi by 2, what I am doing? I am multiplying this one with 2 and dividing with 2. Multiplying with 2 and dividing with 2. So in integration, there is one rule, property. Integral 0 to 2a f of x dx can be written as 2 as coefficient. 2 integral 0 to a. Integral 0 to 2a. This is the formula I am saying ma. This is the formula. Integral 0 to 2a f of x can be written as 2 integral 0 to a f of x dx. The 2 can be written as coefficient like that. 60 into 2 integral 0 to pi by 2 sin power 4 theta d theta. So 60 into 2 you know ma, 120. This value we can evaluate like this. M by m minus 1. Formula ma, this is m by, that means m minus 1 by m, sorry. M minus 1 by m into m minus 3 by m minus 2. Like this you need to multiply ma, till you get 1 by 2. If you get 1 by 2, multiply that one with pi by 2. M minus 1 by m minus 3 by m minus 2, m minus 5 by m minus 4. Like that you need to subtract till you get 1 by 2. Now here m is 4. 4 minus 1 by 4. 4 minus 1 by 4. 4 minus 1, 3 by 4 into 4 minus 3, 1. 4 minus 2, 2. You got 2, 1 by 2. When you get 1 by 2, stop subtracting. Stop doing that procedure. Simply multiply with pi by 2. So see here 4, 2, 2. 4, 4 are 16. If you divide, if you cancel this one like this we will cancel first. 4 1 are 4 3 are 12, 30. 2 1 are 2 15s. 15 3s are 45. Pi. One more 2 is there. This is the answer. Are you clear ma? Using that formula we evaluated. Any doubts you can express ma. Change of variable in double integral ma. So we need to change the given variable in one form to another form. For changing a variable in double integral from one form to another form, like this. For example, to convert from Cartesian form to polar form, if you want to convert, then what you need to do, you need to take these substitutions. Substitute x as r cos theta, y as r sin theta. And the general standard formula to transform double integral from one variable to another variable, here double integral over r f of x comma y dx dy equal to double integral f x is r cos theta, r sin theta. So dx dy, here you need to evaluate Jacobian, next dr d theta. So the Jacobian of r cos theta, r sin theta value we need to write. You know Jacobian how to evaluate. If you want, I will evaluate roughly. Jacobian of these two functions, dou x by dou r, dou x by dou theta, dou y by dou r, dou y by dou theta. What is dou x by dou r? If we differentiate with respect to r, differentiation of r 1. So cos theta, differentiation of cos theta minus sin theta, minus r sin theta. Differentiation of y with respect to r, sin theta. Next, you will have differentiation of sin theta, cos theta. Now multiply r into cos theta, cos square theta, minus into minus plus r sin square theta. If you take r common, what you will get? Cos square theta plus sin square theta will be 1. Cos square theta plus sin square theta will be 1. Then Jacobian will be r. Then what I am saying, this is the standard formula f of xy dx dy equal to double integral f of r cos theta comma r sin theta r dr d theta. That means if you want to convert given problem from Cartesian form to polar form, you need to do these substitutions. Replace x with r cos theta, replace y with r sin theta, replace dx dy with r dr d theta. Why you got this r? This is standard formula to convert a double integral from one variable to another variable. If you have some other function also, if the relation between x and some other variable is given, for that also we use the same procedure. Generally, we convert given Cartesian form to polar form. So we will discuss one problem on this concept so that you can understand how we are going to convert the given problem from Cartesian form to polar form. By transforming into polar coordinates, evaluate double integral. This is 0 to a square minus x square root of x square plus y square dx dy. Integral 0 to root a square minus x square root of x square plus y square. Here these are limits in terms of x, they are y limits, these are x limits. That means given limits will be like this: x 0 to a, y will be 0 to root a square minus x square. That means y is root a square minus x square. If you squaring on both sides, y square equal to a square minus x square. That means x square plus y square equal to a square is a circle. X square plus y square equal to a square is a circle. It is evaluated in positive quadrant, first quadrant only, like this. First quadrant only. So 0 to a. Okay, first quadrant only. We need to convert this one to polar coordinates. For that, we need to substitute x r cos theta, y r sin theta. In the place of dx dy, you need to write r dr d theta. What about limits? Limits. Here very clear, theta is from 0 to pi by 2. First quadrant, right? theta is from 0 to pi by 2. R radius is given. R is from 0 to a only. Now we are going to evaluate this one. Double integral root of x square plus y square dx dy. So this is 0 to a square minus x square. Theta equal to 0 to pi by 2. R equal to 0 to a. You know, in this we already evaluated x is r cos theta, y is r sin theta. Then what happens, ma? Here only I am going to evaluate. X square plus y square equal to r square into cos square theta plus sin square theta. Cos square theta plus sin square theta is 1. So x square plus y square equal to r square. What is r? R is root of x square plus y square. So we can write in the place of root of x square plus y square r by using this relation only. So you can replace in the place of x square plus y square r, and dx dy will be replaced with r dr d theta. R dr d theta. Now what is r into r? R into r is r square. R into r is r square. What is integral r square? Integral r square. Integral r square is r cube by 3. Limits from 0 to a d theta. Limits from 0 to a. Now write in the place of r a. If you write in the place of r a, what you will get? A. So if you write in the place of r a cube by 3, you will get what remaining you are having. Integral theta equal to 0 to pi by 2, 1 d theta you are having. So now a cube by 3 integral 1 d theta 0 to pi by 2. So a cube by 3 into, write in the place of theta pi by 2 ma. If you write in the place of theta pi by 2, pi by 2 you will get. So a cube pi by 6 is answer. 3 2s are 6. Or pi a cube by 6 or a cube pi by 6. Pi a cube by 6 is answer. Clear ma? Any doubts you may express. Now we need to evaluate this double integral 0 to a, 0 to root a square minus y square, x square plus y square dy dx by changing into polar coordinates. The given system is in Cartesian form. We need to convert that one to polar r comma theta. So for that, you know, what is given limits first identify. The given limits are, these are in terms of y, they are limits of x. So these limits are y limits. So given y equal to 0 to a and x is from 0 to root a square minus y square. From this what you understand, x is root a square minus y square. What it means? If you square on both sides, you will get x square plus y square equal to a square. X square plus y square equal to a square is a circle. Is a circle which is taken from first quadrant only. Circle first quadrant region, because 0 to a first quadrant. That means positive region 0 to a. Up to here only, this region only evaluated. And we all know that in polar coordinates, this line we will call it as theta equal to 0 line, and this line we will call it as theta equal to pi by 2 line. That means in polar coordinates, the region of integration for theta is 0 to pi by 2 and r range is 0 to a. And what are the substitutions we are going to do to convert a Cartesian system to polar system? In polar coordinates, in polar coordinates, what happens, man? In polar coordinates, x will be r cos theta, y will be r sin theta. X r cos theta, y r sin theta. Dx dy will be r dr d theta. And limits are very clear. Theta is from 0 to pi by 2, r is from 0 to a. So if you want, you can write theta is 0 to pi by 2, r is from 0 to a. Now evaluate that integral. Integral 0 to a, integral 0 to a square minus y square, x square plus y square dy dx equal to integral theta equal to 0 to pi by 2 integral r equal to 0 to a. You know very well, when x is r cos theta, y is r sin theta, x square plus y square. X square plus y square is x square plus y square will be r square cos square theta plus r square sin square theta. Cos square theta plus sin square theta will be 1. Then what you will get? R square. So x square plus y square will be replaced by r square in polar coordinates. That means r square you will get. What is dx dy r dy dx? R dr d theta. R dr d theta. So now the limits are constant limits, one can evaluate in any way. That means first with respect to r, next with respect to theta. What is r square into r? R into r square will be r cube. R square into r is r cube. Integral r cube. What is integral r cube? Integral r cube is r power 4 by 4. Integral x power n. X power n plus 1 by n plus 1. Integral r cube. R power 3 plus 1 by 3 plus 1. 0 to a d theta. Now write in the place of ra. If you write in the place of ra, what you will get? A power 4 by 4 will be constant. A power 4 by 4 will be constant. What is left over term? Integral 1 d theta 0 to pi by 2. What is integral 1 d theta? Theta. So a power 4 by 4 will be there. Here you will get theta 0 to pi by 2. Now write in the place of theta pi by 2. What you will get? A power 4 by 4 into pi by 2. So a power 4 into pi, or pi a power 4 by 4 2 is 8. So this is the evaluation of given integral by changing Cartesian to polar. Are you clear, ma? Now we are going to discuss in reverse way. Instead of converting polar to Cartesian to polar, now I am going to discuss one different one, polar to Cartesian. Polar to Cartesian. For that, so here by transforming into Cartesian system, Cartesian coordinates, evaluate the integral 0 to pi, integral 0 to a, r cube sin theta cos theta dr d theta. That one we are going to evaluate by transforming into Cartesian. That means given problem is in r theta. Now we need to convert that one in terms of x and y. For that, you all know that this is actually 0 to pi. 0 to pi means he had taken first this part. That means a2 minus a. Because 0 to pi, this is theta equal to 0, this is theta equal to pi. Minus a to a will be x limits. X limits will be minus a to a. And y limits we need to write in terms of x. Because that is a circle, x square plus y square equal to a square. Then y limits you will get from minus root a square minus x square to plus root a square minus x square. So here y limits will be positive only from here to here, right? Not from here to here. That's why you can take y limits like this. 0 to root a square minus x square. Y will be positive only. 0 to root of a square minus x square y limits, because y is positive from here to here, not from here to here. That's why y will be in positive limits only. Now you know very well dx dy will be r dr d theta, and this transformation you know, in the place of r sin theta x equal to r cos theta, you can replace x and you can replace r sin theta with y. Now the given integral will be like this. I am writing given integral as it is 0 to pi 0 to A. This R cube I am splitting into 3 R's. R into R into R cube. Like this. R sin theta, one R cos theta, another R dr d theta. Now I am going to replace, I am going to substitute that values. In the place of R sin theta I can write Y. In the place of R cos theta I can write X. In the place of R dr d theta I can replace dx dy by taking Cartesian limits, that is x from minus a to a. X is from minus a to a, y is from 0 to root a square minus x square, r sin theta is y x dy dx. So now because y limits are in terms of x, first integrate with respect to y, keeping x constant. Keep x constant, integral y square by 2 dx. Limits ma 0 to root a square minus x square. So what you will get finally? Integral minus a to a, I am writing 1 by 2 here, this 1 by 2. Write in the place of y root a square minus x square. Root a square minus x square whole square will be a square minus x square dx. Just now I said ma, if you have minus a to a limits in integration, there is one property in integral. Integral minus a to a f of x dx equal to 0 if this one is odd. If it is even, to integral 0 to a. So now we need to evaluate this one is odd or even. Clearly what we are getting, when we will say one function is odd, if you replace x by minus x, if you get minus x, then that is odd. If you replace x by minus x, if you get same x, then that is even. For that I said one small technique. X square is even, x is odd. Here you are having x. So this becomes odd. Even though you have x square in the internal term, if you write here in the place of x minus x, this will be x square. But if you write here in the place of x minus x, what you will get? Minus. Minus that function. If f of minus x is minus f of x, that is odd, then this is odd function. If it is odd, integral minus a to a f of x dx is 0. So the total value will be 0. 0 into anything 0. Are you clear, ma? This is one different problem in which we are going to transform polar coordinates to Cartesian. This one. This is Cartesian to polar. From these two problems, you can easily understand change of variable from Cartesian to polar, polar to Cartesian. Are you clear, ma? Any doubts you may express.